konnichiwa, or hello in Japanese. So this is our lesson on polynomial functions and their graphs, part of Unit 7 in polynomial functions. So today what we're going to do is we're going to talk about polynomial functions and their unique vocabulary, not only with the algebra, but also with the graphs themselves. We'll take a look at relative extrema, we'll take a look at end behavior, and also the exponents themselves. Okay, so that's what we'll do today. And starting off with polynomial functions and their graphs. Don't let that equation fool you, or at least intimidate you, because that is just going to be our generic polynomial function. To tell you the truth, n represents any value, and then it's going to continue down as far as -1 all the way until we are left with just a constant. Okay, these n values, that's just the leading coefficient or the leading degree. So polynomial functions are functions of more than 2 algebraic terms. Polynomials must have integer exponents, to be called polynomials. Also, an interesting fact about polynomials is that they are always continuous and have a domain of all real numbers. Okay, so when we're talking about domain, we're talking about x values, because as it continues in the x direction, starts off in negative infinity, and it will continue, even though it looks very vertical here, it will continue to positive infinity in the x-axis, or the x in the domain. Now range we're going to talk about later, and that's just because of we're going to see that with even and odd, and also your exponent, determining whether or not the end behavior is going to both go up or go one up and one down. So when we're looking at polynomial vocabulary, so when we're talking about our polynomial, there's distinct vocabulary for each term, and we've talked about coefficients and constants this year, and also exponents. But when we're looking for terms, the number and variables being multiplied together. So there are 3 terms in this polynomial. One of them is, well, you can type it in here, or you can just go ahead and write this. It's up to you. The 3 terms are 8x to the 4th, 13x, and -6. Now the coefficient, remember, that's the number in front of the variable. Okay, so that is what's being multiplied by the variable itself. So in this problem, it would be 8 and 13. Now our leading term, that's the term at the very beginning, is just 8x to the 4th. Now the leading coefficient is the coefficient right in front. So it's the one that's leading the way. In this case, we're just talking about the number itself, not with the exponent. If you were talking about leading term, that would be 8x to the 4th. Now a constant, that's the number standing all by itself. So with x being 0, that constant is going to stay the same at -6. And then if we're looking at a degree, if we're looking at the degree of the term, then we must look at the leading term and look at the exponent of the leading term. Okay, so if we're looking at the leading term, the exponent would just be 4. So this is a 4th degree polynomial. Or we're going to see down here, it's a quartic polynomial. Quartic meaning 4. Okay, now if you forget quartic, you can always say the 4th degree. If it's to the 5th, we can say the 5th degree 4th polynomial, and any number after that. Okay, but at the very beginning, that is a constant. This is not really a polynomial per se, because y equals 8, it's one term, not many terms, it's a monomial. So on this graph, it would just look like y equals 8, 1, 2, 3, 4, 5, 6, 7, 8. It'd be a horizontal line at y equals 8. Pretty boring, 0 slope. But anyway, when we're looking at a linear equation, it does have 2 terms. Remember, we're basing this off of the leading term, okay? The exponent of the leading term, or the degree of the leading term. So in this case, it's 1. So that's going to be linear because it's to the first degree. Second degree, quadratic, we've been working with those. Cubic would be to the third degree. Quartic would be to the fourth degree. This is going to look a little different depending upon what's going on. Let's go up. Okay, so that could be positive or negative. And to the fifth degree, we would end up with just fifth degree polynomial. Alright, so that's naming polynomials based off of their degree. We can also, well, here's the types of graphs of polynomial functions. So when we're talking about, not the types, I'm sorry, it's the relative extrema, where the graphs change from increasing to decreasing or decreasing to increasing. We talked about this with quadratics, but it wasn't relative. We were talking about that as a maximum or minimum based off of the vertex. Because remember, with polynomials, we're going to end up continuing on to infinity either at the end behaviors. Okay, so this would be the ultimate maximum. Okay, and we don't really use the term ultimate maximum, but technically the point values, or if we're looking at this value, that would be higher than our relative maximum here. But this point here would be a relative max, because relative to the graph, that would be, or this section, if we're just looking at this section, that would be a relative max for that equation. But when we're looking at the entire graph, it does continue on increasing to positive infinity. So we do have a relative max and a relative min, and it's based off of the fact that the graph is going to slowly increase, get to a point, then it's going to continue on decreasing, and at that turning point, that is going to be our relative max and our relative min. Let's talk about some end behavior. So when we have end behavior, define the end behavior using a and n. Recall that a is the leading coefficient, n is the degree, the leading exponent, but does not equal 0. Because when we're talking about that, let's just use this cubic function. So y equals ax to the third plus b. When it says a, that's going to be our leading coefficient. And we're also looking at n, which is, alright, so when we're talking about the exponent, that part is n up here, and a is your leading coefficient. Okay, your leading coefficient, if it's positive, is going to tell you always start with the right end. Okay, so leading coefficient tells you the direction of the right end. So if it's positive, that means that the right side of your graph is going to be positive. It's going to continue up in the positive direction. If it is negative, like this one over here, -1, your right side is going to continue on to negative infinity. All right, so that's going to tell you what's going on with your coefficients, and then next time, on the next slide, we're going to talk about what the exponent is going to do to the left side. Let's go ahead and do that. Now, the degree depends on what's going on the left side, but we have to first start off with the right. Okay, so if it's positive, our right side is going to be positive. Okay, but our left side, the left side of the function, because of the 3, if it's odd, it's going to be opposite. So whatever the right side is, this is going to be opposite to that side. So if it starts off negative, our leading coefficient's -1, and then our degree is odd, that means it's going to end up being positive. So we're going to start off and have it as a positive to a negative. And if you think about it, if you're graphing a line, like a slope to a linear equation, the slope would tell you overall that that's going to be a negative slope. And if this is positive, it would be a positive slope overall. Because remember, linear equations are linear, and it's just to the first power, and that's odd. All right, so let's take a look at the fact, or when we have even. So whenever we have even, which is a quadratic or quartic graph, they are going to have the same in values as the right side. So depending upon what that leading coefficient is, your a value, if it's negative to begin with, your other side is going to be, your other side will be the same, which is negative. Also, so we're going to start off positive on the right side. Left side's going to be positive because this is even. Your exponent's even. This is also going to get into the maximum and minimum, because if you notice, our maximum here is only going to be 3 overall. We're never going to go to positive infinity with the range on this one. So this is going to affect range depending upon the degree. So if you have an even degree, our range would end up being all real numbers. Okay, but notice how with it, I'm sorry, I said even, I meant odd. If you have an odd degree, our range is all real numbers. But if you have an even degree, your relative, our max, is going to be the maximum of the graph. So in this case, the y value, so this is going to end up being y is less than or equal to 3 for just the range. So it's going to affect it. And then the range on this one, okay, is going to be negative, it looks like 5.5. Okay, so that means that the y values, everything above, so y is greater than or equal to negative 5.5 or about, because I'm not entirely sure what that decimal is going to be. So we are going to have kind of a, for domain, it's all real numbers. But for range, you have to double check when it's even, because we are going to have a little bit of a different answer for the range on those polynomials. All right, that concludes this lesson. Have a wonderful day, guys, and I hope you guys are doing well. Please see Miss Young if you need any extra help, or if you're falling behind and you're not remembering how to do some of these things, go back and watch some of the videos and then seek help from Miss Young. Have a great day. Bye.